This is a response video to a Learn Electronics video on logic and transistors. So I hope you enjoy it. A transistor. Connect it to there. And to there. Open. There and there. Open. There and there. Yeah, 3 legs. 7, 1, 7 between there and there. Seven, 2, 1, say, between there and there. Now I haven't looked this up yet, but I'm going to make a prediction, of course, that is the base. The middle one, that voltage is lower. The collector on the transistor is normally bigger than the emitter because it has to collect the electrons, and it's harder to collect than it is to emit. So that's normally a bigger area, which gives it a lower voltage drop across it. So I'm going to say that is the collector, which makes that one the emitter. Now if we look at the chip, or the transistor, sorry, it's that way around. Right, we'll just zoom in. I'm using the microscope for this, so it's not the best camera. There we go. C1850, and we'll pop up a data sheet, and there you go. C1850. The emitter is on this side, the collector in the middle, and the base on that side. And what did I say it was going to be? The same. See, you can work out the pinouts from the diode drop. Now back to the main recording. Well, here we have it. 5 volts coming in, 120 ohm resistor, white LED to the collector, emitter back to the power supply, and the other leg, the negative leg of the power DVM up here, and this is the positive one. Now if I move it to there we can see 5 volts. If I move it to there, 5 volts. And as with Learn Electronics and Repair, move it to there, we have a lower voltage because we are pulling slightly, we're trying to pull current through a very high impedance because it's not conducting yet. And just to confirm, nothing on 0 volts. And then we go to the base. Nothing. Now you might ask, why did Learn Electronics get a much higher figure? And that's an easy one to answer. If you watch, oops, put it out of the way, put it back. If I hold the probe in my hand, you can see already we've got a more negative voltage than before. And if I put it on there and hold it, spear it and hold it down, now you can see the voltage is minus 22 millivolts. If I bring my other hand in, Now if I go up and hold a light bulb, a light fitting, or a mains cable, or put my hand near the screen, no, that doesn't affect it so much. Up near my meter, camera lead, bit of solder reel. But you find it's, if I hold, if I touch things, it all changes. But if I take me out of the equation, then there's very little. If I move it over here, a bit more, because I've got a 1.2k resistor in the base. I didn't have a 1k in the through hole components. So there we have it. If I can find a piece of wire, bit of wire, if I connect that to the base, LED is on. If I take it off, LED is off. If I put it onto there, hold it, this one's got quite a bit of gain. You can see I can actually light it just by holding it, but connect it to the ground and it's definitely off, and I can't encourage it to go on because of the low impedance loop to the ground. But it's doing what it should do. And if I hold that on there, we have 0.742 on the base. Hopefully the transistor is fully saturated. 96 millivolts on the collector, and again, a few millivolts on the 0 volt lead because of the resistance of the leads. So I think that kind of explains one bit of it. Let's try with a handheld meter and see what happens. A handheld millivolt meter on the base, 325 millivolts minus. If I plug it on and let go, and now you'll see it's hunting all over the place. And if I hold the leads in my hand, it goes up even more. I auto set the range maybe. Now auto setting the range, it's not leaping around so much. But again, if I bring my finger in or bring my hand in, you can see that those strange voltages are in fact me. Let go, down it goes. So I hope that helps. I'm not going to go into the fact of whether this is a buffer or an inverter or whatever. As far as I'm concerned, it is a buffer. A high on the input produces a light, or a high on its output, which is the light. So it's just a definition of what is the input and what is the output. In this one, the input is the base and the output is the LED. And if I was using this on a circuit to indicate the signal on a output of a chip, then I would call it a buffer, because it's buffering the output and it's indicating what the state of that output is. So I'm going to stop here and thank Learn Electronics and Repair for giving me something to talk about, as I haven't been feeling too great of late. Well, a few days anyway. So if you'd like to hit the buttons, subscribe, notification bell, catch you on the next one.